Hi, my name is Elise, and today I will be teaching you how to complete a grade 12 Calculus and Vectors Velocity Acceleration Application question. The question is in the McGraw-Hill-Ryerson textbook on page 109, number 16. The position function of an object moving along a straight line is s of t equals to 2t cubed minus 15t squared plus 36t plus 10, where t is in seconds and s is in meters. A. What is the velocity of the object at 1 second and at 4 seconds? What is the object's acceleration at these times? B. When is the object momentarily at rest? What is the object's position when it is stopped? C. When is the object moving in a positive direction? When is it moving in a negative direction? D. Determine the total distance traveled by the object during the first 7 seconds. And lastly, E. Sketch a graph to illustrate the motion of the object. A question such as this is valuable because velocity and acceleration are found in our everyday lives, such as when driving, playing sports, and viewing projectile motions. I will briefly read through the question again to highlight key concepts. A. What is the velocity of the object at 1 second and 4 seconds? What is the object's acceleration at these times? This section of the question is found in Unit 2, Derivatives, because we know that velocity is found by taking the first derivative of a position function, and acceleration is found by taking the second derivative of a position function. For the rest of the question, B to E, we will mostly be using Unit 3 curve sketching. This is because in B and C, we are asked to find when the object is momentarily at rest and when it's moving in a positive or negative direction. This involves critical points, such as turning points and points of inflection. In addition, in question E, we are asked to sketch a graph of the function, which is directly from Unit 3. So let's get started. Just for us to get an idea of how the function looks, I put it into Desmos graphing calculator and graphed it. First, we are going to solve for the velocity of the object at 1 second and at 4 seconds. Note, the question states at 1 second and at 4 seconds. Therefore, we are solving for an instantaneous rate. We will do this by finding the first derivative of the position function, which will give us the velocity function. Sub in 1 second, which will give us 12 meters per second. Therefore, the velocity of the object at 1 second is 12 meters per second in the positive direction. Now sub in 4 seconds to the velocity function, and we'll get 12 meters per second. Therefore, the velocity of the object at 4 seconds is 12 meters per second in the positive direction. Now we need to solve for the acceleration of the object at these times. We can do this by finding the second derivative of the position function, or the acceleration function. Now we can sub 1 second in, which will give us negative 18 meters per second squared. Therefore, at 1 second, the acceleration of the object is 18 meters per second squared in the negative direction. Now, sub 4 seconds into the acceleration function, and we get 18 meters per second squared. Therefore, at 4 seconds, the acceleration of the object is 18 meters per second squared. B states to find when the object is momentarily at rest and its position at these times. An object is momentarily at rest when its rate of change is 0, which means turning point. Using the first derivative, set it equal to 0 and solve for t. Thus, these are the times when the rate of change of the object is 0, therefore at 2 seconds and at 3 seconds. Now sub 2 seconds and 3 seconds into the position equation and solve. This will give us the distance the object was at. Therefore, at 2 seconds, the object is at rest at a distance of 38 meters, and the object is at rest at 3 seconds at a distance of 37 meters. In 16C, we need to find when the object is moving in a positive direction and a negative direction. We know the turning points 238 and 337 since we just solved for them in Part B. This function being degree 3, we know that it follows the basic cubic function just for guidance. By placing a pencil on a point on the graph, we can ensure the slope is positive. Therefore, the object is moving in a positive direction from negative infinity to 2 seconds, although time is not negative, and from 3 seconds to infinity. Again, by placing a pencil on the function, we can determine where the slope is negative. Therefore, the object is moving in a negative direction between 2 seconds and 3 seconds. In 16D, we must determine the total distance traveled by the object during the first 7 seconds. A common mistake is to sub 7 seconds into the position function, which gives us 213 meters. We will use this for the calculation, but this is not how you solve for the total distance traveled, but the distance of the object at 7 seconds. First, solve for the y-intercept of the function by subbing in 0 seconds to the position function, which gives us 10 meters. Then find the overall distance traveled by the object. So add 28 meters, which we get from 38 meters in the positive direction minus the starting point of 10 meters, plus 1 meter, the distance traveled in the negative direction, plus, in brackets, 213 meters, the distance of the object at 7 seconds, minus 37 meters, because that's where we left off. Therefore, the total distance traveled by the object during the first 7 seconds is 205 meters. (16E) asks us to sketch a graph of the function. We already know from previous sections that the turning points of the coordinates 238 and 337, as well as the y-intercept is 0, 10. We need to solve for the point of inflection by setting the second derivative equal to 0 and solving for t, which gives us 2.5 seconds. Then define the distance at 2.5 seconds, sub it into the position function, which will give us 37.5 meters. Since it is only a sketch, and we are using time, which is only positive in this question, it is not necessary to solve for the x-intercept, since it will be negative. We know this because there is a coordinate on the graph 0, 10, where the x value is 0. Therefore, following the pattern of this degree 3 function, we know that the x-intercept would be when the x value is negative. Lastly, a career related to this Calculus CCT is that of a statistician. Statisticians need to know how to solve for intervals of increase and decrease, and they use graphs modeled by functions. Therefore, using the main principles of calculus and vectors, statisticians can figure out how fast an object, such as a rocket, will get to a certain height, or the acceleration of an object at a certain time. Additionally, statisticians can be used in financial institutes, engineering consulting firms, sports, and medical research agencies. Thanks for watching.